Okay, so we'll continue looking at the indirect addressing mode, and let's discuss some of the things that you should not do when using indirect addressing. First of all, we already know that the move instruction can only be used when one of the operands is a register and the other one is a memory operand. Both the operands cannot be memory operands. So when you use indirect addressing scheme, it is sometimes students make the mistake by writing move. For example, if in this case array 1 and array 2, let's say, are of the same type, that is word. So if you write this move ESI comma EDI, then this is an invalid instruction. And the reason is that both these operands are memory operands, which is not allowed. Therefore, you should never have both these operands as indirect operands. Secondly, if you have a variable over here in your data segment, for example variable 1, which is of type let's say word again, and it has been initialized with, let's say, 0 hexadecimal. So now if you write move variable 1 comma ESI, then this is also an invalid instruction. And the reason is the same, that both these operands are now memory operands. This is a variable, so obviously a memory operand, and this is indirect addressing, so you're using the address of the array which is inside ESI, and you're accessing a location in memory. So this is also a memory operand, and since both operands cannot be memory operands, this is an invalid instruction. Next, another mistake that is usually made is when, for example, you're trying to write a program in which uses indirect addressing, and you want to access all the different elements of array 1. So now if you use indirect addressing to add up all the elements of array 1, so let's say you say move AX comma 0. So we are using AX because ESI is pointing towards array 1 and array 1 is of type word. So now we say add AX comma ESI. So this will access the first element of array 1, and that will be added to AX. AX currently has 0, so we in effect have 0 added to the first element, which means the first element will now be in AX. And then using a loop statement, we can go back, and now we have to increment ESI by 2, so that next time it goes through and it comes to this instruction, by that time ESI would be pointing towards the second element, so that the second element can be added to the first one. So now we have added 2 directly to ESI, which contains the offset of array 1. However, some students, they try to do this. Now this is not a good idea, because you are wasting a register that is EDI. You do not need to add a register to ESI which has the offset and then add something to EDI which is basically an increment in that offset. So what you should do is, or the better practice is, to do it like this. So now you're using one less register and it's still working, right? And now if you have a loop statement here, L1 for example, then this statement will be repeated X number of times, and X is the number that you have put inside the ECX register. For example 10. So this loop will be repeated 10 times.